5C, statistical tables and graphs. In this section, we are going to discuss basic types of tables and graphs you'll see in a typical statistics class or in statistical research, starting with what are known as frequency tables. And we'll do an example later of what a frequency table actually is. But a basic frequency table has two columns. The first column lists all the categories of data. And the second column lists the frequency of each category, which is in the number of data values in the category. Again, we'll do an example a little bit later. But these frequency tables lead us to, they also kind of are related to what are known as relative frequency. And the relative frequency of any category is the fraction or percentage of data values that fall in that category. And there's a formula for actually determining relative frequency. And that is basically the frequency in the category divided by the total frequency. Again, we'll do an example a little later. There's also cumulative frequency, where of any category is the number of values in that category and the preceding categories. Also, something that we need to know in these definitions here is known as data types and what is known as binning. Qualitative data consists of all values that can be placed into a non-numerical category. Like, for example, non-numerical could be like, colors or measurements, things like that. Excuse me, not measurements. Quantitative data represents measurements. Qualitative data is more non-numerical categories. I'll get to that in a little bit. Now, when dealing with quantitative data, it's going to be useful to what's known as group or bin the data, and to cover a certain range, and I'll explain that also in a moment. But before I get to that, why don't we go ahead and do an example of different types of data. For example, let's go and classify each as either qualitative or quantitative. So part A, brand names of shoes in a consumer survey. Well, that would be qualitative. Brand names are non-numerical, like Nike, Reebok, Adidas, whatever. Heights of students. Well, heights of students are actual measurements, so you could probably actually guess what that would be. You're right, they are measurements, therefore it is quantitative. So again, non-numerical are qualitative, numerical are quantitative. So what about the audience ratings of a film on a scale of 1 to 5, where 5 means excellent? Now you might actually think to yourself, well, this is going to be quantitative because we're talking about numbers. But actually, this is going to be qualitative because, yes, we are using numbers 1 to 5, but these numbers are a subjective opinion based on the subjective opinions about a film. So these are actually not measurements. Therefore, these data are qualitative, even though we are using numbers. So you have to kind of be careful because qualitative does mean non-numerical, and we're dealing with numbers here, so you might think this is quantitative. But this would be an example of a qualitative survey, a survey that's collecting qualitative data because it's based on opinion. So let's go ahead and take a look at a bunch of data. Let's say there are 20 scores listed here from a 100-point exam. So let's say I gave you an exam, and these were all your guys' scores. So this looks like a pretty good score spread here. It doesn't look like too many people did poorly on this one. So let's hope that's our scores for our next test. What we're going to do is we're going to go ahead and determine appropriate bins and make a frequency table. And I think it's best just to go ahead and give you the table right away and we'll discuss. So here's the table here, right? And you'll notice that we have frequency levels here. Now, you'll notice also that the scores are in bins. And you'll notice that the bins are 70 to 74. And that's actually 5 points. I know you might think it's 4, but if you count 70 itself, 70 to 74 is actually 5 different grades. So you have 70, 71, 72, 73, 74. That's 5 different scores. And then we go up to 75 to 79, and then we go up to 80 to 84, so on and so forth. So it looks like this person who created this frequency table created it with bins of 5 in mind. And you'll notice, well, where do they get the 4 from? Well, that's what frequency means. If you look at this entire list here, that means there should be 4 scores that are between 70 to 74. So if I go ahead and look through this list, I want to look for numbers that are between 70 and 74. So I'm still looking through. I don't see any yet. Okay, there we go. 72 is one of our scores. 72 again is another score that's between 70 and 74. Here's 74 itself, and then again another 72. Notice how, let's go to the top here, that only one person scored in the upper 90s. So that's what that means. So let's look for that person. Let's see. Okay, there's that person right there, 98. If you scan through the rest of the data, there's no other person that scored higher than 95. So that makes sense. There's only one person that scored in this range. So hopefully that makes sense. The frequency means how many people landed in that range. Now the relative frequency is you take the frequency here, so for example 1, and you divide it by 20. 1 divided by 20 is 5%. 2 divided by 20 is 10%. Let's go down to something that's a little more challenging. 7 out of 20, 7 divided by 20 is 0.35 or 35%. Now the cumulative frequency is you take all these classes here, or bins I should say, and you add up the previous bins. So for example, there's only one person that got in the upper 90s, right? Well, there are 3 people that not only got in the upper 90s, but also got in the 90 to 94 range. So for example, this person who got 98, well, this person not only got 98, but obviously they surpassed the 90 to 94 range. So they obviously rank at least in this range as well. So this number 3 here includes the 2 from this bin of 90 to 94 and the one who got the upper 90s. This 6 down here includes not only the folks that got from 85 to 89, but also the ones that got in the 90s as well. So you'll notice it's 3 plus 2 plus 1 gives you 6. And then again, 3 plus 3 plus 2 plus 1 is 9. 7 plus 3 plus 3 plus 2 plus 1 gives me the 16, and so on and so forth. Now there are different types of graphs that we need to consider as we move forward with this, with these data. You can use bar charts are very convenient and visually appealing way to represent data. Also pie charts. Keep in mind though that pie charts must always represent the total relative frequency of 100%, and that each wedge of the pie chart is proportional to the relative frequency of the category it represents. So let's go and look at a couple examples here. So here is this is actually some information, some data that we were given. Let's say 4 people in the class got A's, 7 people in the class got B's, 9 people in the class got C's, 3 people in the class got D's, and 2 people unfortunately failed. Well, a bar graph of this data right here would look like this. Notice that my A students, there's a height of 4. The bar has a height of 4. My B students has a height of 7. My C students has a height of 9, and on down the line. Whereas a pie chart looks something like this. Now, it's pretty obvious that because I have more students getting C's than in any other bin, it's pretty obvious that my pie slice for the C's is going to be the biggest, with the B's being the second biggest, and then A's next, D's is next, and then F has the smallest pie slice, thankfully, in this case. So here's some examples of bar graph and pie chart. Also important for labels for graphs, I just want to go ahead and talk about this with titles and captions. The graph should have a title or a caption or both that explains what is being shown and, if applicable, lists the source of the data. So that's going to be very important. Also, a vertical scale and title. This is going to help you along the vertical axis to see what we're actually trying to describe, what sort of data we're trying to label. The horizontal scale and title does the same thing. So this also gives you kind of an idea, and you want to also title it so that way you can describe what we're dealing with. Now, obviously, a legend always helps, knowing what, whether you want to use legends for colors or just simply to decipher information is also important. We also have something called histograms in statistics and line charts, and I'll give you a couple examples in a moment. So a histogram is a bar graph. So we already seen a bar graph, but this bar graph has a natural order with bar widths and specific meaning. Whereas a line chart is very similar. It's actually describing a histogram, just with a little bit of a different twist to it. I'll show you in a moment. We also have what's known as a time series graph. I don't really deal with these as much in this class, but those are also very useful. In this case, the time series graph is a histogram where the horizontal axis represents time. So here's a couple examples. On the left here I have a histogram where in fact, it looks like this is actually this is the data from earlier that when we talked about that one student got something in the upper 90s and 2 students got in the 90 to 94 range. So this actually represents that same data using a bar graph. So feel free to go back to the previous slide if you want to compare to the list of numbers I gave you earlier a few slides ago. And this is known as a line graph. So it's basically, if you notice, it has almost a similar shape to the histogram. This line chart looks almost the same. It kind of goes up, 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 and then down, 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 just the same way. And notice it kind of peaks out over here, over the 75 to 80 range, just like my bar graph does. Okay, taking a look at this here, you'll notice that we have a table of Academy Award winning actresses through 2017. So making a histogram based off this information will be what we see next. Now, what I would ask of you right now is please pause the video and try it yourself. Try to go ahead and quickly sketch out what you think a histogram based on this data would look like. Now that you had time to maybe create a bar graph for yourself or a histogram, does this make sense to you? So notice that on this little line down here, these are their ages, how old these actresses were. And as you can see here, we have just over 30 actresses, 32 actresses that were between the ages of 20 and 29. And you'll notice that this first bar is exactly that. It's just a little bit over 30. The biggest category are the actresses between 30 and 39. You'll notice that bar is a little bit higher, and then it kind of just adjusts accordingly, with 80 to 89 being the smallest, along with 70 to 79. So there you have it. I hope this histogram works. And then notice in the background we have also a line chart. The line chart, what it does, it starts here at the x-axis, and it draws a line straight to the top of the middle part of the bar here. And you'll notice that each one of these points is in the middle of the bar at the top. And that's how, and they just connect the dots at that point. Here's another type of line chart. This is called a time series diagram. As I mentioned, I don't really emphasize these as much, but they are very useful. So I'd like to discuss this data we see right here. Notice that this one's talking about homicide rates in the United States over the years. So if you see here in the 1960s, there were about 5 or 6 deaths for every 100,000 people, and then there was a little bit of a dip, but then it's just kind of skyrocketed in the 70s and just kind of stayed up pretty high for a while and peaked out here in 1980, looks like. And it just remained high for a while. And if you notice, like it's still pretty high, even though it dipped a little bit here in the mid 80s, just went back up again. And then something happened here right around 1992, 1993, something like that, and it just kind of dropped dramatically until here, like the year 2000 or so, where it kind of remained like at a plateau. And then from here, it went from 2008 to 2012, it started dipping again. Now, one would hope that these would keep going down, down, down as we become hopefully a more civilized society. Maybe, I don't know, maybe this is this decrease right here attributes to maybe the police crackdown on gangs and drugs. I don't know. Or maybe this goes back to section 5B, talking about should you believe this statistic. Are these homicides not being reported? Are they trying to dampen down the numbers to make it look better for some political aspirations or something? So there's a lot of different possible conclusions, but this is known as a time series graph, a great way to read statistics and statistical data, given that it is hopefully a good data, like the data was gathered in a way that was honest and fair.